We will now see about active record associations. This subject is quite a pain on the neck for most students the first time they encountered it. However, with a lot of practice and taking into consideration all of the conventions that are necessary, well, then it gets easier and easier. So you really need to get on exercising, applying all of this, and in a matter of weeks, you'll become quite proficient. So associations are connections among active record models, and there are different types of associations. We saw this at the end of the last class, so I won't go into further detail in this slide. There are quite a few types of associations, such as the belongs to, the has one, the has many through, has one through, and has and belongs to many. We will also cover in this video another more advanced type of association, which is the polymorphic association. So the belongs to association will set a one-to-one connection with another model. So each instance of the model in which the association is declared belongs to an instance of the other model. If you've got books and you've got authors, then the books will belong to authors, right? So if you go to the book model, it is reasonable then to specify that a book will belong to a certain author, right? The belongs to association, as it appears here, you see that the target model type is singular. Author is singular, right? So belongs to associations must use the singular term always. In this case, author as in the example, right? So if you use the pluralized form, it will fail. If you try to create something like book, create authors, and you pass in an author model, well, it won't succeed because Rails will infer the desired class name from the parameter name that is put explicitly, in this case, authors. Rails will try to look for an authors model, but the authors model doesn't exist. The model that really exists is author in singular, and that's why this form will fail. So here we've got the necessary migrations for this example to work. Note that the books table will contain a foreign key reference to author, which is specified with the syntax that appears here. T.references author will create a foreign key to the authors table. Okay. Then we've got the has one association, which is also a one-to-one association, but means that the declaring object contains the other object. Okay, so in this case, we've got suppliers and we've got accounts. So a supplier will have one account, and that makes total sense, right? We can even specify a bidirectional association so that a supplier has one account and an account will belong to a supplier. Okay, so the necessary migration looks like this. We'll have an accounts table with a foreign key reference to supplier, and as the supplier will have just one account, we can add that restriction to the references, a method called as we see below, t.references supplier index unique. That means that there can be just one foreign key to the supplier, right, from the account. They cannot be repeated. That means that a supplier that cannot have more than one account by this definition here in the index. Yeah. So then we've got the has many association. Back to the books example, we've got authors and we've got books. So an author will have many books, right? And a book can belong to an author, of course. So you can also take the bidirectional association by combining both and putting on the book side of the association, on the book side of the, we could say, of the relation. We can put belongs to author, to a single author, and an author may have many books. In case you got books with many authors, well, perhaps the belongs to won't work. Then you'll have a case of a sort of end-to-end relationship, many-to-many relationship, and we will cover that later, okay? So the migration for this example will create authors and books tables, wherein the books table will contain a foreign key reference to authors. And you see that in the line that says t.references author. That means that a foreign key will be created. Then we've got the has many through association. In this example, we've got patients and physicians. So one patient will have many physicians and one physician will have many patients through the intermediate appointments model. You see that the appointments model will have foreign keys to both to both the physician and the patient. So the appointment is a model that will contain this information and also contain the date of the appointment. If we see the classes, we can see that a physician has many appointments and a physician has many patients through appointments. There's where you see the through parameter for has many patients through appointments. Okay. Then if you take a look at the appointment class, you'll see that an appointment belongs to a physician and belongs to a patient. And finally, a patient will have many appointments and will have many physicians through appointments. This is the code that will create the tables for this example. We got the physicians, we got the patients, and then we've got this appointments table that will reference both physicians and patients through foreign keys. So if we consider a code such as this, physician.patients, and then we try to assign a collection of other patients, what will happen in this case is that new appointments models will be created automatically for the newly associated objects. And if some existed previously that are now missing, then the appointments will be automatically deleted. We've got that also the has many through association can be very useful in case you've got nested has many associations. In this case, we've got a document. The document will contain many sections. In turn, a section will contain many paragraphs. So it's natural to think that a document will contain many paragraphs, right? But we cannot accomplish that directly. I mean, it is necessary in this case to specify an association between document and paragraphs. You see it in the document class. The document has many paragraphs. However, the association is accomplished through the sections model, which has direct association with paragraphs. The section will contain many paragraphs. So this will enable accessing the paragraphs from the document objects. You can take a document and ask for the paragraphs and you will automatically get them. You see, no need for SQL, no need to ask for all the different sections and consolidate all of the paragraphs in the different sections. You can just ask for all the paragraphs in the document by doing this. Then we've got the has one through association, which can be thought about as a special case of the has many through. Here you got suppliers, you got accounts, and you got account history. So a supplier will have a unique account and an account will have a unique account history. And this is accomplished through the associations that you can see in the different classes. So the supplier class will have one account and will have one account history, although it will be through account. You look into the account class and it will belong to a supplier and it will have one account history. Then you look at the account history and you see it belongs to an account. So the has one through association is implemented in the supplier. The supplier has one account history through account. Because account, if you see the underlying database table, it will contain a foreign key to the supplier. And it will also contain an account number, right? And it will contain, the account history table will contain a foreign key to the accounts table. So the migration looks like this by incorporating foreign key references in the accounts table to supplier and foreign key reference to accounts table from account histories. Then we've got the has and belongs to many association, which is the standard way of associating objects in models in a many-to-many relationship. Whenever you see that the join table it doesn't make sense to use it as a model. In this case, you see that you got assemblies. Assemblies are composed of many parts, and a part belongs to many assemblies, right? So we've got a join table, which is assemblies parts. This table will contain foreign keys that are necessary for the association to work, but won't add any other information. So assemblies is a model, parts is a model, assemblies parts isn't a model, it's simply a table in the database. And you see that in to the right side where you see the code of the two classes that are involved, the two models. You got the assembly model and you got the part model. And both will declare a has and belongs to many association, specifying the other end of the association. In the case of assembly, it's parts. In the case of part, it is assemblies. So the corresponding migration for this example is the one you see here. We got assemblies, parts, and assemblies parts tables. You see that the assemblies parts table's sole purpose is to act as a join table, as a junction table. Therefore, it will declare foreign key references to assemblies and parts. Finally, last but not least, we'll see the most advanced kind of association we've got. You see that we've got picture, we've got employee, and we've got product. Both of the latter, that is employee and product, may have a picture, right? So we want picture to be related to employee and product. So the way we do this is to specify that the picture will belong to some imageable model, right? And it is a polymorphic association in the sense that imageable can be an employee or a product. Here you see that then employee has many pictures as imageable, and product also has many pictures as imageable. So in this case, a picture may belong to either an employee or a product. The employee may have many pictures and the product may have many pictures as well. The latter means that if we got employee.pictures, it will work, and product.pictures will also work. And now if we got a picture, we can ask for the container class, the container model. For instance, if we could take a picture and ask for imageable, then this will result in an employee or a product. And here you can see how this is implemented in the database. We got the employee model, the products model, and the pictures model. You see that the pictures model will contain two special fields, the imageable fields. The name of these fields will depend on the name you put in the belongs to method call within the picture class. Here we put belongs to imageable, but it could be any other verb ending on able, you know. Could be, I don't know, yeah, and well, in this case, imageable. It could be any, as I said, any verb that ends with able. So imageable ID and imageable type. Imageable type can be employee or product. Imageable ID is the foreign key to either employee or product. So if we see the migration to the right side, you'll see that the references method call will specify imageable and imageable polymorphic. So I hope you've been able to understand the basics of active record associations, and in a later video I'll show you a few examples of the basic associations in an actual Rails project. Thank you very much for watching.